Now, in this particular topic, we're talking about congruency and similarity. Let's take a look at checkpoint 8.2 part A. Okay, they're actually giving you two different triangles here, so let's just do a little bit of a highlight. This is the bigger triangle, the one yellow, okay, and then you have the one in blue over here. Okay, this is actually asking you to find length, so therefore let's find the length of DC over here. So you just compare, you want DC, this is what you want, right, over EC. Okay, because why? We know that the triangle AEC is similar to triangle BDC. Now, how do I know? You know that the angle ACE in a sequence of 1, 3, 2 is the same as the angle of BCD, also in a sequence of 1, 3, 2. Why? Because they are common angle, right? Yes. So you know that all of the angles are the same. So given that they are similar triangles, you can compare the sides. Okay, so based on whatever they gave you, put in BD over AE. Now you notice one thing, that I'm actually putting the small triangle over the big triangle. Now can you put big to small? Of course you can. Okay, but what I'll normally do is I'll tell my students, use whatever they gave you. Alright, so let's just substitute in. Now one important thing I want you to learn over here is this. Okay, you have ED, so therefore that means 7 plus DC. Can you see? It is this and okay, this one should be EC. Okay, because we are comparing the small is to big, right? So it should be EC over here. Okay, so therefore it will be 7 plus DC, and then let's continue. BD that is given is 9, AE is 12. So let's cross multiply 12 DC plus 9 times 7 plus DC. Okay, so what should you be getting here? You should eventually have 3 DC equals to 63, and DC equals to 21 cm here. Okay, yep. So then let's take a look at 8.2 part B, okay, where you're asked to name a congruent triangle as well as a similar triangle. Alright, so in this question, okay, let's do a little bit of a highlight again. They're asking you to find a triangle that's congruent to EFG. So you have E, F, and G. Okay, congruent to E, F, and G. So what we have, okay, you have the directly opposite. Now why do I say that? You have F, E, D. Can you see? They are the opposite. Why? Because, okay, let's say this is E, F, G congruent to F, E, D. Because FG is given to be equal to ED. Correct now? This is given. You know that the angles, or rather, you know that the base is the same. So FG equals to EF. Okay, EF equals to FE. It is also given. Am I right? Alright, so you can see that they're actually both the same. Okay, then you have your FD and DE because they are diagonals. Correct now? So you know that these two triangles are congruent. So this part A, your answer should be triangle FED. Now please be very careful to check your sequence, okay, whenever you actually name your triangle. Now I realize a lot of students, they don't like to check their triangles, so please make sure to check like how I did here, okay? Then you have the triangle that is similar to EFH. Okay, so let me give you a blue. EFH, where is it? EFH. So we are looking at this triangle. Okay, so what is a similar triangles that I'll give you? Remember the hourglass looking kind of diagram? You know that these two triangles are the same. So we are looking at FHD. Can you see? So the question is, okay, in what sequence should I do it? So it will be triangle EFH is similar to, alright, the answer should be triangle DGH. Okay, because you see that this angle is the same as this angle, correct? These two angles are the same. These two angles, the shaded ones, are also the same because of alternate angles. So in similar triangles, as long as you prove two angles, you know that they're similar. Okay, so please be very mindful. Again, your sequence does matter. So please take care of that. Then let's take a look at EHF. Okay, EHF is this particular angle here, the one that I'm shading in red. Okay, so EHF, alright, EHF, Now, once we know that this particular angle, okay, so you have EFH, because it's similar, okay, you will say that it is also DGH, so they're equal, correct? So it means that this is also 41. Then you know that by alternate angles, okay, the one in purple, by alternate angles, you also know that this is also 41, correct? So in a triangle, you have 180 minus 41 minus 41 to eventually give you what answer? 98. And then this is angle sum of triangle, whatever we learned in the previous chapters, right? So therefore, angle EHF equals to 98 degrees. Okay, now we're not done. Let's take a look at part D. Alright, this is the length of EG. Okay, so let me just erase this because it's not very visible now. So you have EG. Okay, that's what they're actually looking out for, right? Then what they do is I'll take GH, which is the small triangle. So small triangle, you know that it's a small one, right? So let's follow this, the one I highlight in yellow now, follow this sequence again. So, okay, so you have GH, which is here, to FH. Okay, and then you have GD, which is second to first, to FE, also second to first. Okay, so sub in your values, you would have 6 FH equals to GD, which is 10, FE, which is 25. Cross multiply, you will have FH equals FH, yes, FH over here, okay, which actually shows you that this would be, sorry, this one should be, oh sorry, I want this to be EH actually, okay, shouldn't be FH, EH, okay, so EH 10 equals to 150, so EH equals to 150 divided by 10 equals to 15, okay, so therefore EG is actually equals to EH plus HG, right? So you have 15 plus 6, which is in the end 21 cm. Okay,